I hope that you can hear me. Um, I can barely see what I took a picture of, so hopefully I have the right numbers. So let's start again with that problem. I believe that the main thing was I started with that +3 when I should have listened to you and used 0.03. But again, let's start off with what we know, which is a good strategy for you. Write down everything they tell you. The first investment, they invested $1,200 at a certain interest rate. And then they invested $2,200 at another interest rate that is 3% higher than the first interest rate. The total annual earnings were $253, and the higher investment earned $125 more dollars. All right, so let's make a table very similar to the one that your teacher made. So we've got our first investment, principal rate times time. Second investment, principal rate times time. Principal rate times time is equal to interest, if you recall. So again, I'm going to call this first and second investment. So this is going to be the first one. This is going to be the second one. The principal of the first one was $1,200. The rate of the first one, we don't know. So we put X. The time, as I told you before, is annual, so it's just a year. So that's constantly a 1. Second investment was $2,200. The rate was X plus, as you were mentioning, 0.03, and that's what I should have used instead of 3. And of course, the time is still 1. So this is 1200x, and this is 2200 times x plus 0.03. Now, the total earnings from these investments was $256. So I'm going to start out with $253. And that's going to equal 1200x plus 2200 times the quantity x plus 0.03. Now, we get 253. I'm going to learn how to read one day. And that's 1200x. Let's go ahead and distribute that 2200. That'll be plus 2200x plus 66. Not 6600. Move that 66 over, we get 187. Add these two together as like terms. So we subtracted the 66 and got the 187. Add these two together and we get 3400x. And we divide and find the first interest rate. Now when we divide here, our interest rate is going to be written as a decimal. We want it to be written as a percent. When we divide, we end up with 0.055, which as a percent, all you gotta do is multiply by 100 per 100, 5.5%. That is the first interest rate. The second interest rate is x plus 0.03. Well, since x is 0.055, and we're going to add 0.03, that'll give us 0.085 for our second interest rate, or 8.5%. And you can multiply these through and see that it is true that the higher investment earned $121 more. But we don't have to wait. We can do it right now. 1200 times 0.055 is equal to $66. That's how much interest the first one earned. The second one, 2200 times 0.085 gives us $187. And 187 is $121 more than 66. So that's that one. Now let's look at the second one about the trains. What we know about this is that at 12 p.m., 12 noon, one train headed east left Bridgeton traveling 90 miles per hour headed to Cogville. Now, if I've got these numbers wrong, please let me know later. Another train at 15 minutes later, it left Cogville headed to Bridgerton, traveling at 100 miles per hour. And we need to know at what time will they pass each other because they're headed towards each other. This is different from going apart from each other and doing a total distance. This time, these two distances are, headed towards each other. We want to know when they're going to pass each other. Two trains passing each other, hopefully on different tracks. So we know that totally the distance between Bridgeton and Cogville is 450 miles. First train's going 90 miles per hour. That's its rate. The time, we know it left at 12, but we don't know how many hours it's been traveling, so we put an X. This one's going 100 miles per hour. We know it left 15 minutes later. So I'm not going to put a plus here. I'm going to put minus for 15 minutes. And instead of putting 15, I'm going to put 0.25. So minus 0.25 because it's 15 minutes later for its time. All right, so when we do this, it's going to be 90x is equal to 100 times x minus 0.25. Now, why am I setting them equal? Because they're headed towards each other. We want to know at what time are they going to meet or pass each other. So when we're doing that, when they're headed towards each other, we make them equal. When they're going apart and we want to know the total time that it took them to get so many miles, we add them. Little thing with a big thing. All right, so 90x is equal to 100x minus 25. Bring the 100 over. We get 100 or 10x negative is equal to negative 25. So x is equal to 2.5 hours. So after 2.5 hours, wow, look at that 5. It's beautiful. This first train's 90, well, x is equal to 2.5 hours. They're 2.5 hours apart. So the first train is traveling 2.5 hours. The second train is traveling x minus 0.25 or 2.25 hours. And again, you can check. 90 times 2.5 is equal to 225. And 100 times 2.25 is equal to 225. And if you add those two together, you get 450. So we actually did that right. Hope that helps.